All right, hello and welcome. So we're going to have a quick look at the Frayer model to help us learn a couple different terms with the algebra topic. So the specific one that your teacher wanted you to cover was the second one down here, and we're going to look at the term patterns and what that means. And to show you, if you haven't seen the Frayer model used before, this first one's going to be like an example one that I'll do for you, just so you can see how to fill out the 4 different sections. The whole point of this Frayer model, by the way, is to help you get to a point where you understand the word better. So within this algebra topic, you're going to see, the word patterns. You're going to see that used a bit. You're definitely going to see the word simplify used a lot throughout the topic. And if you don't know what the word means, it's going to make the whole topic a whole lot more confusing than it needs to be. So often you'll find your teachers, and in this case your Year 7 teacher has decided to use the Frayer model just to help you get a better understanding of some of the terms you're going to see a lot in this topic before she actually goes in and starts teaching it. So that's why we're doing it. Anyway, let me show you with this first word how to actually use a Frayer model. So we got this word simplify. And you'll see it's been split up into 4 different sections. The first section is the definition. No tricks here. This is just where you write down what the definition of the word is. So we look at what simplify. We look at that word and we think about what it means in the context of algebra, and whether you need to look in a textbook, whether you already know what the word means, and then you can just write down the definition in your own words, or whether you need to look online. It's totally up to you. But ultimately, the first section is to write down a definition of the word. So what I'm going to do is I'm just going to write down a definition. Simplify. All right. To rewrite an expression in a more simple way. Okay, so we're not actually changing the expression at all. We're just rewriting it in a way that looks a little neater, is ultimately what it means. Now, the second section, you go across, you look at the facts, or sometimes it's called characteristics. So here, you can put down one, you can put down a couple, it's up to you, but just a couple different facts or things about the term that you're looking at. And again, we're looking at simplify. So simplify. So what's a fact? It doesn't change the original meaning. So if you simplify something, you're not actually changing what the thing means, right? All you're doing is you're just rewriting it in a way that's neater. So there's a fact there. That's really kind of all you need, but you can, write down extra facts and stuff as well if you want. There's no real rule. You just write down sort of what comes to you. All right, the final 2 sections is the example section over here on the left, and the non-examples over on the right. Let me explain. The example section is the easier one to do, and it's going to make more sense. In fact, you may already know what to do, but this is a situation where you show an example of what that word means. So let's say, as my example, I put down simplify x plus x plus x. So in this case, we have ourselves an expression, x plus x plus x. And again, remembering back to, when we first looked at algebra, right? These letters, they're actually unknown numbers. We don't know the value of it, so we just call it a name. In this case, I'm calling this particular number x. I don't know what the value of x is, but we've got 3 of these numbers and they're all being added together. Now we're going to simplify it. That means we just need to rewrite this. So to simplify x plus x plus x, I guess the easiest way you could simplify it would be to rewrite this as we have 3x, or in other words, 3 lots of x. So instead of x plus x plus x, we just have 3x. It's the exact same thing. It's just been written in a more neater, more simple way. So that would be an example of simplify. Now, over here on the right, a non-example. All right, so this is where you would put something similar but doesn't actually mean the same thing. So let's say instead of x plus x plus x, we had, say, 4 plus 4 plus 4. Now, in this case, you would not actually simplify because we actually know the values of x. So instead, for this non-example, because we know the value of the numbers, it's 4 plus 4 plus 4. We don't simplify, we can actually evaluate. So you would actually come up with the answer. So my non-example is something similar to it, but instead of a simplify, it is an evaluate. Evaluate is where you can actually find the value. Go ahead and find the value. Simplify, right, is when you can't find the value because you don't know what at least one of the numbers is. So if you can't evaluate it, you're stuck with, well, I'll at least simplify it, right? I'll at least, write it a bit neater. So that would be my non-example, evaluate. All right, so this is how the Frayer model works. So you have your term in the middle, you got your 4 different sections to fill out. Now, the one that your teacher wants you guys to do is this one here. So it's the word patterns. Now, again, remember, we're talking about algebra. So what you're going to end up needing to do is fill out these 4 sections for patterns. And just to remind you of what patterns is in algebra, because you may not have seen this since term 1 of the year. Here's a pattern, right? I've got a bunch of sticks that have been combined together to make a pattern of triangles. And if you look at the pattern that gets formed, the first triangle, how many sticks did we need, right? So if you just look at that first triangle here, see we needed 3 sticks. By the time you have 2 triangles, how many sticks did you need to make 2 triangles? End up with 5. And you keep on going through and you end up with this number pattern. This here is a pattern. And of course, you often get those questions that ask you to fill out, the final 2 or the final 3 numbers or whatever it happens to be. And then eventually, you come up with a rule and that sort of a thing. But so this here is an example of a number pattern. Okay, so this is what Miss is talking about when she's talking about patterns. So what I'm going to get you to do is pause the video here and have a go at filling out the 4 sections yourself. Once you've got answers for all 4, unpause the video and I'll come up with some potential answers as well. All right, so hopefully you've had a chance to go through, you've paused the video and you've actually done this yourself. Again, your answers may be slightly different to mine and that's totally okay. But hopefully you'll be able to check off with mine to see if they're similar enough. You know that you're doing the right thing. All right, a potential definition. Now, if you actually looked one up, yours is probably going to be way better than mine. But I'm going to put down for my definition of patterns a sequence of numbers that follow a rule, some sort of a rule, right? Okay, so that's going to be my definition. Some facts about patterns. Can be, number patterns. That, may involve pronumerals. So, for example, what I mean by that is here's a number pattern, right, that involves pronumerals. What's another fact, you might have had for patterns? Like, they involve numbers. The number patterns can go up, they can go down. Rules or equations can be created, for each pattern. etc. So I guess there's lots of different things you could write down in that facts section. Examples. All right. So, here I'll use this example. Here it is. Here's an example of a number pattern. A pretty basic and boring one, but there's an example. You might have done something a little bit more interesting. Here's another example where we're going up by fives. Here's one where we're going up by fives and then adding one, etc. Like there's lots of different, you could have ones, maybe ones where here we're going down 10, 5, 2.5, 1.75. We've got a situation where we're halving here. That's another, there's heaps, you only need one or two examples there. Hopefully you got some examples of some patterns. And okay, some non-examples of patterns is something that would not be a pattern. So let's say you've got, something that's going up by threes. Maybe we got by fours here. It's actually looking like a pattern, right? We've gone up by 3, we've gone up by 4. The next one would be to go up by 5. Let's say, I just put down a 1. And now I'll put down a 3, and now I'll put down a 0. And now I'll put down, 102. There's no pattern here, right? We do have a sequence of numbers, but they're not following any rule. Like they're randomly generated. So this would not be considered a pattern. You wouldn't be able to create, there's no rule that they're following, so there's no equation that could really be created. So that would be a non-example. All right, I'm going to leave it there. Hopefully you understood what was happening. If you need to go back and rewatch any parts to help you make sense, feel free to do so. If you have any questions, just leave them here in the video or back through Canvas, and I'll see you for the next one. Okay, bye.